All right, friends, we're going to review all of the problems in that review section for Chapter 3. I'm starting here with number 371. I've solved these and I've tried not to skip too many steps for you so you can see all the algebra bits. So the first problem is 371. We're going to use the definition of the derivative, the difference quotient, to find the derivative of the square root of x plus 4. So this is the definition of the derivative. So the limit as h goes to 0 of f of x plus h minus f of x all over h. And so what we're going to do is we're going to plug in our values here. So f of x is just what we're given. And then remember, f of x plus h, we're just going to substitute x plus h every place we see an x. So there's an x right here in our f of x, and so I'm going to substitute x plus h in there. And then that gets us to this point, so this is what we look like. And then because we've got different kinds of radical things going on here, things under the radical sign, we're going to go ahead and use we're going to multiply by the conjugate here to get rid of these, to see if that can't help. And so remember, the conjugate is the same thing, only we're going to switch the signs here. So this is a minus. So over here, and I put this in red to highlight that you have to remember to switch this to a plus. Since we're multiplying that numerator by a value, I also have to multiply the denominator by the same amount because we want to keep the value the same. And this is just 1, right? This is a form of 1. Something divided by itself is just 1. Multiplying by 1 doesn't change the value. So I did skip a little bit here. We're just looking at the numerator right now, my friends. We're going to FOIL that. So when I multiply the first two terms, notice all that's going to happen is just the radical sign is going to go away. And that's right here. The inner term and the outer term are going to cancel. That's the whole point of multiplying by the conjugate. When I get the last terms, this is a negative, this is a positive, so the answer will be negative. And then again, we're just going to remove those the radical sign there, because it's the same thing. When you multiply them together, you get whatever the argument is inside the radical. In the denominator, notice I'm not going to simplify this. Just leave it alone, because the grief was not with the denominator, it was with the numerator here. So just leave this alone. This will take care of itself in just a moment. Then we're going to simplify this. Over here, I wanted to make you aware that when you have this subtraction sign and you have parentheses, that negative sign needs to distribute across everything inside those parentheses. So this becomes negative x minus 4, because that negative needs to distribute over there. So then you see here that everything, or not everything, I shouldn't say that, but many things are going to start canceling, because I have an x minus x, I have a plus 4 minus 4, and all I'm going to be left with in the numerator is just an h. Now, the reason I didn't want you to multiply that bottom is because the denominator is because, notice, this will very easily allow us just to cancel these h's. So then when I do that, I'm back over here, and I have the limit as h goes to 0 of f of x plus h, there's a little typo there, plus 4 plus x squared of x plus 4. And then we're just going to substitute in 0. So when I plug in 0, this h goes away, and then I have 2 of the same thing. And so I have 2 times square root of x plus 4. And that's the answer, which is this in a different form, which you notice that if you had solved this with the chain rule, this is x plus 4 to the 1/2. We would use the chain rule, bring the 1/2 down front, take 1 away from 1/2, which is negative 1/2, and leave that right there. Leave the u alone. And 372, same problem, same thing. We have 3 over x, same thing here. Now, in this case, we don't have to do the conjugate, but I do need to have a common denominator, which I'm just going to multiply these together. Over here, I pulled the numerator out specifically just so we can look at it. I'll put it, once we simplify it, I'll put it back over h. But I'm going to get a common denominator. I'm showing you here how to get a common denominator. And then over here again, we've got this distribution of a negative sign. So make sure that's negative 3x minus 3h here. Go ahead and simplify. And notice I get negative 3h plug that back in, and then from here, when I'm dividing by h, it's the same as multiplying by 1 over h, so I put that right there. And then you see these h's cancel, and I'm left with this. And again, if we used our rule, we know this is 3x to the negative 1. If I take that with the power rule, I get negative 3x to the negative 2, which is this in a different form. So everything's the same right there. Number 373, these are just straightforward and take the derivative. So I have 3x cubed minus 4x to the negative 2, 9x squared plus, because negative times negative is positive, right? 8x to the negative 3. 374, I have a chain rule. It looks like the chain rule I would like to use here, or the substitution would be u cubed. If you do that, then the derivative of u cubed is 3u squared du, where u is the substitution I'd like to make. And if that's the substitution I want, then du is negative 2x. And I plug these pieces into this, and I get this. And for our purposes, you're okay to leave it like this, because you're showing me the chain rule. If you want to write it out, or if in a different circumstance, a different teacher wants to see it written out, you could certainly do that. 375. So we have e to the sine x. That's a fairly straightforward chain rule. So we're going to use our u substitution is going to be u is sine x. So I have e to the u, and the derivative of e to the u is e to the u du. My u is sine x. That makes my du cosine x. Plug those things in here. 376, I have the ln of x plus 2. And we're going to use ln of u, and the derivative of ln of u is du over u. If my u is x plus 2, then my du is 1. And then I have my derivative right there, 1 over x plus 2. 377. This one, it looks like we need to use the product rule twice. So I have a product rule here and a product rule there. So we just separate them and then add them together. So here's my uv, u dv plus v du right there. My second uv over here for the second part, u dv plus v du right there. And that would be the derivative. 378, another chain rule problem. This is a u to the 1/2 problem. So the derivative of u to the 1/2 is 1/2 u to the negative 1/2 du. U in this case is 3x squared plus 2, so my du for that would be 6x. So I can plug all that in there. 379. This one's tricky because we have x over 4, but remember that's just 1/4 x, so that's don't worry about that. This just looks like a uv, a just simple product rule here, except this is our first case where we're having to work with the arc sign, derivative of the arc sign, which is fine. We just look that up on our table. And so I simply do my u, dv, v du, and in this case the dv, the derivative of the arc sign is 1 over the square root of 1 minus x squared. That's the derivative of that. Everything else is the same. 380, in this case, we've got a implicit differentiation problem, and kind of a big one here. So I've got x squared y over here, plus y plus 2, plus xy sine x. So I've kind of chunked this here, so let's deal with this one first. So this is just product rule. So here's that part here. So u dv, remember the derivative of a y is just dy dx, or y prime if you want to think of it that way, plus y times 2x. So that's that part. This is just dy plus 0, right? That chunk right there. Over here, this is where when you have 3 things being multiplied in the product rule, we want to clump 2 of them together, which makes the du or the dv, however you've clumped them, just a tiny bit more complicated. So in this case, I'm going to put these two, the x and the y, together in the u. So then I'm just going to move forward with the product rule just like that. So I have u, xy, dv, cosine x, plus v, right? Then the du is another product rule. And I think we can do this in our head here. So this is u dv plus v du. That's that whole thing right there. And so this, it's not quite in line, but this whole thing is the answer. Now, if you needed to actually find the derivative, you would need to simplify that. And if you wanted to do that, what you would first do is move everything that had a dy, dx in it over to one side. So I did that here for you. Everything that has a dy is on the left. Everything that doesn't is on the right. Then I can factor out those dy, dx's, and then I'll divide by whatever's left over. So in this case, so then you finally have the dy, dx by itself equals this whole thing right here. That's the derivative of that. That's how implicit differentiation works if you actually need to explicitly solve for the derivative. 381. This is like our other one. We have three things being multiplied together. I'm just going to attach these two, the x, ln x, together. So then I have my u dv plus v, and then this, we just take the derivative here. So again, in our head, we have the u, derivative of the ln of x is 1 over x plus ln of x times 1. Pretty straightforward. 382. This was take the first derivative. Okay, this is take the third derivative. So we need to take the derivative 3 times. Again, chain rule. 3x plus 2 quantity squared. So we're going to use u squared as our outer function. So then the derivative of that would be 2u du, where u is 3x plus 2 and the du is 3. So I did that here. And because we need to keep working with it, usually at this point you would want to resimplify to get it as simple as possible. Multiply the 2 and the 3 together, and then distribute that 6. So I get 18x plus 12. Take the derivative again. Well, that's really straightforward. That's just going to be 18. Take the derivative again, and the third derivative is just 0. 383. Oh, here's our tricky one. 4 to the x. And I put the rule over here, right here for you. So anytime we have we like to use e to the x normally, but anytime we don't have an e as the base, we just use this rule right here. So in this case, I think they want us to take the second derivative of this. So the derivative of 4 to the x is 4 to the x ln of 4. And this is just the the product rule, sorry. So x squared times cosine x plus sine x times 2x. That is our y prime, and then we need to do it again, take the derivative again. So then remember, ln of 4 is a number. It is not a function. So we're just going to repeat this and then multiply these together. So I'm going to get the ln of 4 squared. That's just a number right there. Then here, it looks like I'm going to have two product rules. Product rule here, product rule here. So this first one, u v prime dv, right, plus v du. That's for this first one. I put brackets there. Then we're moving on to this one, u v prime plus v u prime. And that whole thing is the second derivative of that. 384. This and the next one, I believe, are find the equation of the line tangent. So remember, we need an x-coordinate, a y-coordinate, and the slope to plug into y equals mx plus b. They give you the x-coordinate right here. So x equals 0. Here's our function. We need to take the derivative in order to find the slope at our desired x value. So here we go with our arc cosine. Looking up on our table of derivatives, we get this, negative 1 over 1 minus x squared plus 1. Now, we're just going to evaluate that at 0. This is 1 minus 0. The square root of 1 is 1. Negative 1 over 1 is negative 1. Negative 1 plus 1 is 0. So the slope is also 0. And then we just need to figure out what y is. Well, in order to do that, we plug 0 into the original equation, right? And then when we do that, let's see. The arc cosine of 0 plus 0. Well, what angle has a cosine of 0? That's where the x value is 0. That would be 90 degrees, or pi over 2. So here's our y value. So here's our three components. And we're going to plug them into y equals mx plus b. I didn't write y equals mx plus b, but I did here. So here's y equals mx plus b. Now, in this case, we get this kind of wacky formula, y equals pi over 2, which makes sense that because this is an oscillating thing that you would have a flat line there. Not the best example, not the best problem. I would have liked one that actually had some values here, but you see the process. Get a slope and find your x and your y. And 385, we're going to do that again. I think this one's a little bit better example because we get some values, not 0. So here's our equation at x equals 1. So when we have 1 over x, that's really x to the negative 1. That'll help you remember to take the derivative without being fussy about that being a rational expression. And so the derivative of this is going to be 1. Derivative of x is 1. Derivative of e to the x is e to the x. And derivative of negative x to the negative 1 is positive x to the negative 2. So there's our derivative. And I went ahead and recomputed this for you because we have to substitute in. And I think it's easier to see it as a fraction rather than as a negative exponent. So we're going to evaluate that at 1. So I get 1 plus e to the 1 is e plus 1 over 1 is 1. So that's 2 plus e. Now, in this case, this is a number, right? 2 plus e is a number, 2 is a number, but I'm just going to leave it like this. You could write it as a decimal if you need to or want to, but we're going to leave it like that. So that's our slope here. Now we just need to find our y value, so I'll plug this into the original equation here. So I get 1 plus e to the 1 plus 1 over 1. Well, 1 over 1 is 1. 1 minus 1 is 0. E to the 1 is e. So my y value is e. So plugging it into y equals mx plus b, I get e plus 2 plus e times 1 plus b. Distribute the 1, doesn't do anything. So I get e equals 2 plus e, subtract the 2, and then actually this would be negative 2, because I got to move that over the other side. That's a minus 2 there. Oops. And so the answer is y equals quantity 2 plus e times x minus 2.